Hello and welcome to Stories of Science. Here, we look back on humanity's long journey to understand the world. The questions, the failures, and the breakthroughs that slowly changed how we see the universe and ourselves. We tell science as stories. Born, the quantum genius who made science and life dance. Can you imagine it? There's this one guy who treated math like magic, and somehow managed to catch the most mischievous particles in the universe. His name? Max Born. Yep, that's the same Max Born who would go on to completely flip our intuition about quantum mechanics. To everyone else, particles seemed like little kids bouncing around, chaos incarnate. But Born, he'd glance at them, smile, and say, "All right, you can be playful, but you've got to play by the rules of probability." Suddenly, quantum particles started behaving playful, yes, but with a little order in the chaos. You might think, isn't this just math? Sure, but Born turned it into magic. Probability, wave functions, uncertainty, they weren't just cold formulas anymore. He gave them personality. Particles were like kittens, and Born was the patient yet firm caretaker saying, "No running off, I'm watching you." Imagine the physics world being told, all of a sudden, that reality isn't fixed, it's a little random, a little mischievous. Minds were blown. Scientists scratched their heads, students panicked, and Born, he sipped his tea in the office, scribbling formulas, playing the quantum world like a virtuoso. But how did a quiet kid from a small German town grow into the man whose ideas made physicists everywhere tremble? How did he uncover the magic hidden in probability and start conducting the symphony of the quantum world? The answers lie in the story that follows. Breslau, a sleepy little town. 1892. Max Born is born. His father, a professor of anatomy, fills the house with the faint smell of dissection. His mother, a musician, fills it with the sound of piano keys. Science and music. Odd mix, right? But young Born thrived in it. He was a frail kid, prone to sickness. Others ran and huffed. He calculated square roots. A cold? No problem. Piano practice? Still on. Math exercises? Every day. Music was his breath, math his playground, a childhood that felt like a complex symphony. His mother passed away when he was just 5. Most kids would retreat into silence. Not Born. He turned grief into curiosity. Thoughts hid in piano notes, numbers filled the pages. Each note a formula, each formula a note. His father was strict but tender. At home, there was a little lab, and Born would sneak in microscopes, test tubes, chemicals. He made magic out of science. Leaves on the street, sparrows hopping by, everything became an experiment. A fallen leaf? He'd study its symmetry and wonder, how would this behave probabilistically? Born asked questions non-stop. Why is the sky blue? Why does water flow around stones? Why are there fewer black keys than white? His father frowned. Born found a way around it. Curiosity bounced like a spring, always popping up new questions. He watched and mimicked. Craftsmen carving wood? He squatted and traced the outlines. Broken clocks at neighbors' homes? He'd dismantle and, astonishingly, fix them. Teachers were amazed and exasperated. Classmates thought he was outrageous but secretly admired him. Who wouldn't envy a kid who could play piano and solve problems simultaneously? Born loved small challenges. He set himself 3-a-day exercises, math, science, music. Complete them? Reward yourself with hot chocolate. Once, he used piano keys to model planetary motion, turning his father's desk into a mini solar system. His father nearly tripped over a tiny ball. Born looked up, innocent. Science has to move to live, right? Through the streets of Breslau, Born rode his bike chasing ideas. A leaf fell, he calculated wind speed. A sparrow perched, he tracked its movements. Sick in bed? He still had paper and pencil. Draw geometry, write probability formulas, play a tune every act, a little bit of childhood magic. His childhood mixed music, math, and science. Sharp, free, mischievous, yet orderly. Frail in body, strong in mind. He learned to bridge logic with rhythm, melody with formula. Sometimes he combined his father's anatomy books with his mother's sheet music and played a formula symphony. Strange to friends, but to Born, pure joy. This was his small universe. Math was a game, piano his breath. His childhood a complex symphony of sadness, joy, mischief, and order. And it's this very symphony that would one day make him the quantum magician, the man who made the world's physicists tremble, quietly growing up amidst piano keys and geometric formulas. Born left Breslau in 1901 and entered Breslau University. A small-town kid facing the true academic world for the first time. He didn't just study one subject. Math? Absolutely. Law? Why not? Physics? Of course. Astronomy? The stars couldn't be ignored. Born was a cross-disciplinary whirlwind. Others queued for courses, he barreled through. Physics? No waiting. He treated equations like toys, solving problems like building blocks, arranging formulas like musical notes. Each subject was a new delight, making him almost dance with excitement. By 1904, he moved to Göttingen University. The professors there were legends: Hilbert the brain of mathematics, Klein the geometry magician, Minkowski the wizard of space and time, all under one roof. For Born, this was academic paradise. In class, he sat front row, yet often daydreamed, imagining equations dancing. While peers took notes, he drafted future formula lists. He wasn't just absorbing knowledge, he was learning how to think. Göttingen's library became his treasure trove, tall shelves like miniature forests. Born dove in, kicking aside books sometimes, only to discover new inspiration. A scholarly squirrel, hiding the nuts of formulas and theorems in his mind. Born's brilliance was connecting disciplines. Geometry and astronomy? He integrated them while drawing star charts. Probability theory? He imagined particles dancing through space. Cross-disciplinary work wasn't a hobby, it was mental training. Outside class, he experimented with crystals under microscopes, tracked planetary orbits on the playground, even tested light refraction in secret mini-experiments. Every test, a curiosity party. Göttingen challenged him. Professors refused easy answers. Hilbert posed tricky problems. Klein made geometry fly off into abstraction. Minkowski taught that space and time weren't linear. Born was forced to combine logic and intuition, filling notebooks with mazes of symbols and diagrams. Where others saw formulas, he saw shadows of the future quantum world. University wasn't just lessons and exams. Born turned it into adventure, each class a map, each book a weapon, each professor a boss fight. He mixed math, physics, astronomy, law, anything to fuel curiosity. Göttingen transformed the small-town boy into an academic thrill-seeker, teaching him to treat curiosity as fuel, imagination as compass, formulas as toys, experiments as games. This would lay the foundation for his later quantum revolution. By 1906, Born had his doctorate, studying elastic lines and crystal structures. Sounds dry? Don't be fooled. In crystals, he saw patterns, nature's secret dance. Each line, each lattice, whispered stories, and Born was the listener, using formulas as ears, experiments as translator. Doctorate done, he headed to Cambridge. Afternoon tea? Scenic walks? Forget romance. He went to challenge giants: Thomson, the father of the electron; Larmor, wizard of atomic rotation. Their minds were heavy with physics rules, denser than any textbook. Born stepped in like a kitten among lions, formulas roared in hallways, laws prowled the labs. He sat quietly, notebook open, absorbing every word, every subtle hint. Then he smiled and sighed, these lions? I'll make them my dance partners. He discussed electrons with Thomson, rebuilt atoms in his mind. Larmor spoke of magnetic rotation. Born sketched a mini-universe. Others remembered conclusions, he recorded the thought paths. Every experiment sparked quantum imagination. Cambridge was brief but intense. Walking the lawns, he'd wonder, if particles were as free as the wind, how would they move? Life and physics blended like coffee and cream, rich and exhilarating. He didn't just learn knowledge, he learned methods, how to question, doubt, and extract order from chaos. The giants didn't hand answers, they forced him to ask, think, and discover. Born loved it. Here, he first sensed the quantum future not as fantasy, but waiting, mischievous and probabilistic. The stage was set, the curtain about to rise. Doctorate in hand, Cambridge experience absorbed, the small-town boy, now Göttingen's academic whirlwind, had become a watcher of the quantum world. Every experiment, every formula, every conversation laid the path to a future that would leave physicists both amazed and powerless. And if you think this was just academic training, no. This was the prologue: probability, mischief, unpredictability. Born's quantum adventure quietly beginning. 1914 World War I breaks out. Max Born is drafted, but he's frail and often sick. Frontline combat? Not his scene. Instead, he takes a desk job in research. While others are firing bullets, he's firing off equations and numbers, formulas, crystal structures. These are his weapons. War rages, but math never leaves him. In 1913, he got married. His wife, she gets him, loves science, appreciates humor. The wedding is simple, yet anyone could feel the sparks of equations flickering in his mind. Home life slowly grows noisy. 3 kids arrive, one later becomes a biologist, keeping the family's scientific streak alive. During the war, his days follow a peculiar, almost ritualistic rhythm. Morning, check experimental data; noon, scribble notes, crunch formulas; afternoon, attend research meetings; evening, family dinner. Kids fuss? Born distracts them with math problems. Who can square 7 the fastest? They scream and laugh. He chuckles secretly in his head. On the battlefield, he fights with equations. At home, he battles the daily family skirmishes. Science and family run on parallel tracks in Born's life. In the lab, he explores crystals, optics, acoustics. At home, he's figuring out how to get kids to eat vegetables. 2 brains at work, high pressure? Of course. But Born finds ways to laugh through it. Formulas and laughter intertwine. His life has rhythm. War changes the rules. Resources are scarce, materials hard to get, papers stall, experiments delay. Yet Born doesn't stop. His notebook keeps turning, formulas keep dancing. A probability, geometry, mechanics. The world keeps spinning, and so does his mind. Family gives him strength. Kids are innocent, his wife is warm. Science becomes a game, home becomes a training ground. Arithmetic with the kids? He's coaching tiny apprentices. Every problem is an experiment. Every giggle is energy. War teaches adaptability. Lab shortage? Improvise. Data lost? Redo. Tough paper problem? Take a walk. Return with the answer. Life teaches flexibility. Math teaches precision. Little did he know, this is the seed of probability thinking that later blossoms in quantum mechanics. He also witnesses the fragility of the world. Bombed streets, neighbors' homes burning, research teams scattered, friends fighting at the front. Born realizes life isn't always controllable, but thinking can be. Probability, formulas, logic, they never leave you. His days seem ordinary, yet tension hums beneath the surface. Experiments, equations, children, his wife, news of the war, all woven together like a complex symphony. Every note pulses, every formula shines. At home, he's father, husband, teacher. In the lab, he's scientist, explorer, rulemaker. Life and research feed each other. Kids learn to think, lab formulas grow bolder. War changes destiny, but math never leaves. Born. Equations, probability, crystal structures, they're all part of his life. Family, war, research. 3 parallel lines teaching balance and order amidst chaos. This teaches him the world may be uncertain, but curiosity, thought, and rules can shape the future. Born scribbles formulas in the lab, soothes kids at home of facing the world's cruelty. He safeguards his own scientific playground. These experiences shape the man who will face war yet conquer the quantum world. A small, frail boy becomes the fledgling master of probability. 1921 Born becomes a professor at Göttingen University. He returns to familiar grounds, not as a student but as a guide. His office, part lab, part playground. His students, future legends, Heisenberg, Fermi, Dirac, names that will echo through time. They debate matrices, wave functions, quantum jumps. Born? He plays the piano. Math and music run side by side. Heisenberg calculates matrices while Born taps keys. The office is sometimes a lab, sometimes a concert hall. Students quickly realize Born's teaching is strange but brilliant. He teaches more than formulas. He teaches thinking of formulas are tools. Thought is the key. He lets students explore freely, but guides them just enough. Quantum mechanics isn't a rigid temple anymore, it's a playground, with levels to challenge and paths to innovate. Göttingen buzzes with curiosity, hallways echo with whispers of probability interpretations, classrooms hum with debates on matrix mechanics, labs vibrate with spectral measurements. Born conducts this quantum orchestra with a pencil wave. Each student plays solo yet contributes to the ensemble. And Born keeps learning. Every question sparks new ideas. He dives into quantum statistics, exploring wave function probabilities. Born knows the quantum world doesn't follow intuition, it obeys math. He teaches students to use formulas to understand nature, not just imagination. He peppers lessons with humor. Think particles will behave? Wrong, they're mischievous. Students laugh. He laughs. Even formulas seem to dance. In Göttingen, rigor and play coexist. It's an intellectual marathon, a high-density brain gym. He fosters independent thought. Heisenberg loves matrices? Explore or Fermi curious about particle statistics? Challenge accepted. Dirac sharp as attack? Learn to trap quantum patterns with logic. Born's office is lab and incubator. Discussions run late. Piano and equations intertwine. Coffee clinks. Notes fill pages. The air buzzes with creativity and excitement. Real scientists don't just solve problems, they chart new territory. Göttingen's golden age isn't just Born's glory, it's the cradle of the quantum revolution. Each formula, each discussion, each experiment hints at the future of quantum mechanics. Born watches students, eyes alight. Mischievous particles, take your time. I'll teach humans to understand you. Office, classroom, lab, piano room. Born's world merges life and scholarship. Every keystroke, matrix, wave curve explores nature and sets the stage for what's next. Rules can be rewritten, limits challenged. Students soar. Born guards order with a wink of fun. Math and music entwine, shaping one legend after another. Göttingen is more than a university, it's a quantum nursery, a training ground for future scientists. Born knows this is just the beginning. Probability, matrices, wave functions, the seeds are planted. The piano keeps playing, formulas keep leaping. The quantum revolution quietly stirs. 1925. Born stands at the forefront of quantum mechanics. Matrix mechanics is born. Sounds complex? Don't worry. In simple terms, it's tying particle behavior into mathematical rules without making them fully obedient. Like a magician controlling smoke and light, but the audience never guesses the next move. Born turns to wave functions. He realizes the wave function isn't a physical object. It's not a particle, not a tiny ball. It's a tool to predict where particles like to play hide and seek. Particles jump, vanish, appear. Wave functions say, most likely here. This probability interpretation becomes the famous Born rule. It's like Born saying, friends, particles have personalities. You can only guess their next move with probability. 1926, the probability interpretation goes public, the scientific world explodes. Classical physicists shocked, uncertainty? Particles playing tricks? Born smiles, using formulas and logic to tame the mischievous particles. Probability reshapes how humanity views the microscopic world. His work extends to solid-state physics and molecular structure. Born-Haber cycles, Born approximations sounds like chemistry spells? Actually, it's Born bringing mathematical magic to chemistry and physics. He helps scientists understand crystal energies, chemical bonds, molecular structures precisely. From theory to practice, Born turns invisible rules into actionable science. In the lab, he's like a child in wonder, discussing equations, probability, predicting particle moves. Students learn to play with matrices, to use formulas to grasp nature. Born on piano, Heisenberg with matrices. The office becomes a symphony. Wave functions leap, particles prank, formulas sparkle, music flows. The quantum world is a stage of magic in Born's hands. Probability doesn't just alter particles, it changes how humans think. The world isn't strictly deterministic anymore. Uncertainty becomes part of the rules. Particles choose positions, electrons choose orbits, humans choose thought, not just chasing certainty, but embracing possibilities. Science becomes flexible and fun. He also studies crystal and molecular structures. Born-Haber cycles reveal crystal formation and reaction energies. Born approximations make complex molecular problems calculable. His methods ripple across physical chemistry and materials science. Born isn't just a theorist, he's a bridge builder, bridging math and physics, theory and experiment, students and future scientists. His formulas aren't just tools, they're keys to the quantum world. Occasionally, he jokes in the office, particles are like kids, mischievous little things. Wave functions are my fireworks. Students laugh, he laughs, easing the tension of science. Rigorous yet playful, the quantum magic unfolds in his hands. Probability rules, matrix mechanics, solid and molecular structures, each step lays the groundwork for the future. He teaches the world, the micro-world is uncertain, but understandable, particles are mischievous, human thinking must be nimble. Born's science is magic, wave functions dance, probabilities flicker, every formula a wand, every rule a spell, particles misbehave, yet patterns persist, math, music, humor, probability all woven together in Born's unique universe. He changes particles and the way scientists think. Humanity learns to embrace uncertainty, to reason with probability. Born's magic belongs not only to the quantum realm but to every thinking mind. Born's science doesn't just dance in the lab, it steps into the world as semiconductors, integrated circuits, lasers, nuclear theory. Every technological wonder bears traces of Born. Next time you power on a computer, brighten a screen, or ride a high-speed train, remember, there's a Born brain quietly at work behind it. Quantum probability isn't just math, it reshapes philosophy and worldview. Once, the world seemed linear, predictable, certain. Now, uncertainty, probability, and possibility are the rules. Born teaches, plans are always outrun by probability. Particles are mischievous. Events are unpredictable, accept uncertainty, understand possibilities. Born's greatest gift. He cared for science and society. After World War II, he attended the Pugwash conferences, advocating nuclear disarmament. Science isn't isolated play, formulas bring power and danger. Responsibility is another track for scientists. Born's wisdom warns, explore quantum worlds, but protect the real one. How deep is his impact? Semiconductors speed electronics, integrated circuits shrink and empower computers, lasers revolutionize medicine, communications, industry, nuclear theory fuels energy and research. Every equation, every probability calculation underpins these miracles. His thinking influences philosophers and scientists alike. Humanity learns to handle uncertainty, not just seek certainty. From economics to ecology, astronomy to AI, probability ideas seep everywhere. Born shows science and life are full of surprises and choices. In his later years, his smile carries humor and reflection. Plans are always outrun by probability. Advice to students? Wisdom for the world. You can plan your life meticulously, but Born reminds you the world is mischievous and spectacular. So next time you marvel at technology or study quantum mechanics, don't forget Born. He teaches us to predict with formulas, to understand with thought. He's the magician of quantum mechanics and the reformer of human thinking. His influence, like microscopic particles, is everywhere, subtle yet profound. Born reshapes particles, reshapes human thought. He makes science flexible, the world fascinating. From a small boy in Breslau to a Göttingen professor, to global influence in science and philosophy, Born's life is a probability curve, jumping, fluctuating, yet pointing to wisdom and responsibility. Next time you enjoy a technological marvel, smile somewhere. A Born brain is quietly manipulating probability. Science is like life, it's full of surprises. Born wasn't just a magician of the quantum world, he was a true cross-disciplinary legend, and his family life? Just as remarkable. His granddaughter, Olivia Newton-John, would go on to become a global superstar. A family of scientists, and yet they could headline a concert. Who would have thought? You can almost imagine Born at home thinking particles dance, and my granddaughter dances too. Music was inseparable from his life. The piano wasn't just an instrument, it was a thinking partner, a melody of formulas. He and Einstein loved to talk physics through music. Want to debate relativity? Forget words, play Beethoven instead. Keys became a bridge to the cosmos, melodies a way to probe the universe. In his office, formulas and musical notes danced together. Born loved to travel too. On trips to India, he wasn't just discussing physics, he immersed himself in culture. For him, scientific visits weren't just conferences, they were adventures across disciplines. He studied architecture, listened to local music, exchanged ideas with scholars. The world, in Born's eyes, was both laboratory and stage. Every journey became a collision of science and culture. Humor ran like a thread through his life, strict in the lab, playful at home, kids, grandkids, music, science, they all became a family symphony, discuss matrices in the office, play piano in the kitchen, life and science ran on parallel tracks, crossing paths just often enough to spark fireworks. Born taught us something important: science can change the world, but families can put on a show too. Cross-disciplinary thinking wasn't a buzzword, it was a lifestyle. Formulas could predict particles with precision, melodies could express ideas, and families could nurture the next superstar. His life was as much a quantum saga as a human one. Rigorous yet humorous, experimental yet musical, scientific yet familial, everything coexisted in harmony. He proved that exploring the world isn't confined to the lab. It can happen across piano keys, on stages, even through cross-cultural journeys. Born's life orchestrated both particle probabilities and everyday surprises, the humor of a scientist, the warmth of family, the spark of musical inspiration, all combined to make him a true cross-disciplinary legend. Remember that frail little boy from Breslau, weak and sickly, yet enchanted by piano keys and numbers, playing hide-and-seek. Math was a game, music a breath. His childhood was a complex symphony, from piano keys to formulas. He let curiosity be his compass. Born's life became a dance of probabilities, from Breslau to Göttingen, from brief stops in Cambridge to global academic exchanges. Every step explored the unknown. He taught us that uncertainty isn't a flaw, it's how the world really is. Particles are mischievous, life is mischievous, the world is mischievous. You can't predict the future perfectly, but you can understand its possibilities. Matrix mechanics, wave functions, probability interpretation, these weren't just formulas, they reshaped physics and the way we think. Probability showed us that particles might move anywhere, yet there's still order to the chaos. Science no longer seeks only definite answers, it embraces multiple possibilities. Life works the same way, plans never outrun probability. The world is trickier and far more fascinating than you think. Born didn't just change science, he embraced responsibility. He joined the Pugwash conferences and advocated nuclear disarmament, understanding that formulas can empower, but also endanger. A scientist doesn't just explore the unknown, they safeguard the world. Probability taught us more than physics, it taught us life. Born's life was cross-disciplinary, piano, family, travel, cultural exchange, all part of his thinking. His granddaughter became a star, music intertwined with science, life infused with humor. He proved science can be rigorous, yet life can be fun, rules can be understood, yet exploration never stops. From a small town in Breslau to Göttingen labs, from family life to the cutting edge of science, Born's life was a symphony of curiosity, intelligence, humor, and responsibility. He showed us the world is never certain, but exploring it is always worth it. Particles might misbehave, plans might fail, life might get messy, but curiosity, courage, responsibility, and thought will guide us through uncertainty. Born's life was a poem of probabilities and a gift of wisdom. Science and life intertwined, formulas and melodies running in parallel. Exploring the world is never easy, but it's always spectacular. Next time you face the unknown, think of Born. Embrace uncertainty, stay curious, and move forward boldly. The world may be mischievous, but the value of exploration will never change. The people who change the world usually just think one step deeper. If this story made you see things differently, hit like, subscribe, and save it. See you in the next story.